Alright guys, we're going to try and learn about factoring by grouping, but we're going to flip it, which means I'm going to give you guys the problems to do and then you can practice the problems in class. So, what I've done for the first two problems is I've already broken them down. I'm probably not going to break them down every time, but just for the first couple, I think it helps. I'm going to find the GCF of the left half, so that's the first two terms, and they're both multiples of 2, oops, I circled an extra 2 there, 2, 3, and x. So they're both multiples of 2 times 3 times x. That shouldn't be circled, should be that. 2 times 3 times x is 6x, and I'm left with 2 times 2 times 2, which is 8x plus, and if I bring the entire thing out, that's 1. So I brought out a 6x over here, and I was left with 8x plus 1. That's 8x plus 1, so I get 48x squared plus 6x. That's back what I started with. Now what I'm going to do is the GCF on the right side. Since this is a plus sign, I need to put a plus sign right here, and then I'm going to find the GCF on these two terms. So the GCF, they have a 5 in common, so I'm going to bring out a 5, and then I'm going to be left with 2 times 2 times 2x, which is 8x, plus, if I bring the 5 out of 5, I'm left with 1. And the cool thing is, if you do this correct, you're going to see the same two binomials here, the same binomial, 8x plus 1 both times. So now that's my new GCF. I bring out an 8x plus 1, and I'm left with, if I bring the 8x plus 1 out, I'm left with 6x plus 5. So that's 6x plus 5. I'm going to leave it for you to distribute. I'm going to do the same thing. I'm going to find the GCF of the left side, so that's the first two terms. They're both multiples of 2m squared, 2m squared. So 2m squared is my GCF, and I'm left with m plus 3. Now I see a plus sign here, so I'm going to put a plus sign, plus, and find the GCF of the right side. These are both multiples of 3, so I'm going to bring out a 3, and I'm left with m plus 3 again. Now that's a good sign that I did this right, because now I have the same binomial twice, so I can say m plus 3, and I'm left with 2m squared plus 3. When I bring the m plus 3 out, I have 2m squared, that plus sign is important, plus 3. So again, you should distribute to check it. I'm going to do two more problems, but these I'm not going to actually break down for you. I'm going to leave that for you. So I'm going to find the GCF on the left half, which is 2z squared, and I'll be left with z plus 6. And now in this problem, there's a minus sign right here. So when I do the right side, I need to put a minus sign. That's going to be minus. And the GCF between 5 and 30 is 5. And I'm left with z plus 6. And that's a really important plus sign. See how this was a minus sign? That's a negative 30. If I bring out a negative 5, I'm left with positive 6. That way when I distribute, negative 5z, negative 5 times positive 6 is negative 30. So I get plus 6 here. If I didn't do that correctly, then I wouldn't have this binomial being the same. So my new GCF is z plus 6. And then the important part is I have 2z squared minus 5. 2z squared minus 5. I have one more problem to do. I'm going to go ahead and find the GCF for the left side, which is 4n squared. And if I bring a 4n squared out of this term, I'm going to be left with just n plus, if I bring a 4n squared out of 8n squared, I'm left with just 2. Now again, I have a minus sign, so I'm going to make sure that I put a minus sign right here, and I'm going to find the GCF between 5 and 10. The GCF would be 5, and I'd be left with n plus 2. Again, this is a plus sign because I brought a negative 5 out. Negative 10 divided by negative 5 is positive 2. When I distribute, I get back to negative 5n minus 10. So now the last thing, I need to find my GCF, which is n plus 2, and I'm left with 4n squared minus 5. So 4n squared minus 5 is my other term. And now I'm done. I want you guys to try and finish the remaining 6 up, and I'll see you tomorrow.